We are now going to see a very interesting simulation of completing the square. So hopefully it will give you a visual understanding of why it's called completing the square and how it can be used to solve quadratic equations. So you can actually change this number to anything you like. You could start with, 34 if you want to change it to 34, and it will update the problem. So for right now, I'm gonna use the default, which is 39. So the first thing that we have to do is arrange it in x squared plus bx is equal to a constant form. So is it ready? Is it in that form already? Yes, right? Because the a value here is 1 and the constant is already separated. So now we're going to complete the square. And how do we complete the square? We get half of the middle number. The middle number is 10. We divide it by 2. It's 5, right? So after we get 5, we square that value and we get 25. So let's see how the simulation illustrates that visually. So first, um, if we remember what we did before in class, we used some algebra tiles, right? So we represented, polynomials by using algebra tiles. So the x squared is represented by this square tile, and the 10x is represented by this rectangle with dimensions 10 and x. So when you get the half of the middle number, what this is actually doing is it's splitting your rectangles into two um, congruent rectangles. There you go. So now this rectangle has area 5x and this is also 5x. When you add them together, that originally came from 10x. So what we're going to do now is we're going to add these 25 to both sides of the equation. So why do we add that? Well, see, you have a composite figure over here. It's not a solid figure. It has a missing part right here. So how do we find that missing side? Well, we're going to fill it up with a shape, that has this side as a length and this side as a width. But since they have two marks, we know that these two sides are congruent to each other. So if we're going to find a shape that will fill this white portion up, it has to be it has to be a square. There you go. So this is 5, so 5 times 5 is 25. So that kind of explains why it's called completing the square, because this entire shape here is actually a square with sides x plus 5 and x plus 5. Okay, so how do we now use that to solve? So going back, let's write down the original problem here. Um, we added 25, right, to complete the square. So now this will become x plus 5, and that actually represents the dimension of, this square right here, x plus 5 squared. And then this is equal to, what's that, 14 carry 1, 64. So now we get the square root of both sides. We have x plus 5 is equal to plus or minus 8. So now move the 5 over, you'll get negative 5. So the solutions are positive 8 minus 5 is 3, and then negative 8 minus 5 is negative 13. So these are the solutions to your quadratic equation, and we solve that by completing the square.